Hello friends, and welcome back to my channel Scientific Factory. And today this video is going to be very much interesting because today I have a question that you can see that why do we use the area of trapezium as half into h into a plus b, friends, where h is the distance, is the height, and a is one side and b is one side. Just you can see in the example here, ABCD is a trapezium where AB and CD are parallel sides. So A is 1 and this is B. And the height, friends, this is the perpendicular distance that is termed as height. So friends, we write as half into h into a plus b, which is also called half into sum of parallel sides that you can see a plus b into distance between them, that is h. Now friends, let's move forward. So friends, before moving forward, at first let me tell you what trapezium exactly is. So trapezium is a quadrilateral in which one pair is parallel sides. So friends, as you can see, AB parallel to CD, but AD is not parallel to BC in this case. You can just see. And friends, just there's a type of trapezium that is called isosceles trapezium. So in this type of trapezium, the non-parallel sides becomes equal. So friends, if I just take AD and BC are non-parallel sides, then AD becomes equals to BC. So friends, these are some important and basic properties of trapezium that I've discussed so far. As you can see that the first property is the one pair of sides are parallel to each other that I have observed here, AB parallel to DC, and in case of isosceles trapezium, then parallel sides are equal. Suppose if we take just ABCDs and isosceles trapeziums, and in this case what do we have is that AD is equals to BC. Now friends, let's move forward towards proving. So before proving, just we must know that area of triangle is half into base into height, and that is very common, and I hope friends you all are aware about it. And the second one is that perpendiculars drawn from the vertices of one parallel sides to another are equal. Suppose friends, if just take an example of this. Suppose if I draw from vertex a perpendicular to base DC, then in this case, and if we draw from B to here, so these both will becomes equals to will become equals, friends, because as we know that in parallel, if AB is parallel to CD, it means that the distance between these two parallel lines are always remain same. So now friends, let's move forward. So what we have just area of trapezium ABCD is equals to area of triangle ABD area plus area of triangle CBD. As you can see here right now, just we have just divided into two triangles, that is area ABD and just BCD CBD. So now friends, let's move forward. That is area of trapezium ABCD is half into base into height plus half into base into height, as I have just discussed that area of triangle is half into base into height. Now friends, in case of triangle ABD, we have FD as height. And friends, in case of triangle CBD, we have BE as height. Our friends, as I have discussed that FD and BE, both are equal because the distance between parallel lines always remain the same. So now friends, let's move forwards. Now AB. So friends, in case of triangle ABD, we have AB as base, and in case of triangle CBD, we have base CD. So friends, what we do is we consider AB as A and we consider CD as B, as they both are the parallel sides. Now as you can see that half into AB into H, because friends FD is equals to B, so that we have taken both as H. As you can see, FD is equals to B, so H, and we take half H common, AB plus CD, and we, as I have just taken, AB is equals to A and CD is equals to B, so just we put and we get half into H into A plus B, which is that half into sum of the parallel sides, that is A plus B into distance between them, that is height. I hope friends you liked this video, and if you liked, then subscribe my channel and press the bell icon and share to your friends. Thanks for watching.